So, just as a matter of starting these discussions, I think we had a great day, and I'd like to again thank all the speakers for a lot of insight. This was truly insightful, and I personally enjoyed it a lot. I hope you enjoyed it too. But at the end of the day, we just wanted to quickly see the lessons learned, perhaps, and also to think about future and what we're going forward. As I said, this is about your questions, so I'm not going to ask any questions. But I know that you may need a minute or two to think about a question. So let me ask a general question first, but then I expect you to please come up with follow-up questions. So I think many of the students here in the room are either undergraduate students, master's students, or PhD students. And I think on the mind of many who are doing bachelor's or master's, the question is that should they continue to PhD, especially in the area of circuit design? And I know that we talked about various aspects of circuit design, different applications. So I'd like to ask the panelists to just go one by one, tell you whether they think you should do a PhD or we should stop at master's and then go to industry at that level. So maybe we could start from you, Arnaud, if you like.
Yeah, on the topic of PhD or no PhD, I would say definitely it depends. It's absolutely not a requirement for future happiness and growth in your career. But if the opportunity presents itself and it's a group that works well for you and a topic that interests you, then why not?
Yeah, I think I'd say the same thing. To me, the PhD is kind of a certification of your ability to research something new on your own. Okay, so if that's the kind of direction you want to go, maybe exploring something a little different, then a PhD is a good choice. But there's lots of great circuit opportunities, and many of my most creative colleagues are only master's or sometimes bachelor's students. So it's really up to the kind of work you want to do.
Yeah, I think I share this opinion that it's all up to you to do a PhD or not. I did a PhD and I would definitely recommend it if you have the chance, because what I found nice is that you go through the whole design cycle on your own. You see the design from scratch, from schematic to a layout, and you see the chip in the lab and you can measure it yourself. And that is often something you cannot do in real life in a company, especially not in big companies.
I also very much agree with what has been said. Depends a lot. Depends on you. And sometimes you're not ready to make that choice when you just finish your master as to am I ready for a PhD or not. A lot of students just go to industry for 2-3 years and figure out, and then they realize, okay, do you have this burning question that you would like to dedicate 4 years of your life on? If so, yeah, perhaps a PhD is a good thing to go to the bottom of it. But yeah, it also give you time to know whether you're ready for the PhD and whether you really want to dedicate 4 years of your life on a question that excites you. I think that's the main point.
I'm number 5 in the row, so what can I add? I would say, especially for the PhD students that were in my group, I was at the University of Delft, as I mentioned already earlier, 1 day in a week. These people had to work quite independently, and I do not know whether you like that, yes or no. I think that also during a PhD, the stress is much less than in the industry. But finally, in the industry, you can work towards products, and that is not really the case these days in a PhD anymore. So it's purely up to your own choice. It's so very difficult to say, yes, you have to go for a PhD, or no, you don't. You go directly to the industry. But I mean, that it so much depends on from person to person, I think. Yeah, and it's very difficult for me or for us, I think, to decide whether you have to go for a PhD. But that's fully up to you. There are a lot of pros and there are a lot of cons. Yeah.
Thanks. So I fully agree to what our colleagues said. So it's really up to you. But what I can add is that being and managing a team of people, and I have 4 or 5 people that are coming from PhD background, and the other are not coming from PhD, so they just graduated and enter into the industry. I can clearly see a difference. So that statistically there is a difference. Then for sure there are some people that didn't do a PhD and then they are really smart, emerging. But statistically I can see a pattern that the people that follow the PhD process, they have something more. So they have some understanding more, some high-level background, so that they are a bit more mature in the work and in bringing result to the table, and also explaining the results, so that they can explain a bit more with high level to low level deepness. This is what I can observe. Thanks.
One thing I could add to that is you might want to try or experience the industry environment in some way before you make the decision. Maybe as an intern, or maybe you take a year off, or maybe as a part-time job. But I think the experience of being in industry and seeing what's important and seeing how things can be used will make all the difference in your subsequent education. It will help you focus where you want to be. It'll help you see what the stuff you're learning, how it's going to be used. And for me, that was extremely motivating. So I'd recommend that you give industry a try. Don't just stay in the university, because you're not seeing the whole picture in the university. There's other stuff going on, and in fact, in industry, the learning curve, when you first go there, the learning curve is extremely steep. You're learning all kinds of practical stuff about how circuits work and how they're manufactured and how they're used. There's a lot of stuff that's just important for good engineering. And so you want to sample that, I think, and get a sense of that. And that will you either decide, no, I'll stay in industry, or it will motivate you to do that PhD.
I do agree, Chris, but there's no way back. Once you step into the industry, I think that it's extremely difficult, not to say impossible, to go back to university and for a PhD. I think once you make the choice to go to the industry, then that's the route that you have to follow. That's the route that you will follow.
Now you've torpedoed my future dreams of returning to academia. I went to industry because...
For a PhD, you want to go back to academia?
No.
Oh, that's another story. That's also what I
actually went to industry because many of my favorite mentors at university had industry experience. And I thought I want to be like them as well. So here I am.
Well, I went also back. For 1 day in a week, I went also back to the university. But then I had my PhD already. Yeah.
Thank you. This is all great advice. And I just want to make sure that we get some of your questions answered. So please raise your hands, and I will volunteer myself to bring you the microphone.
Yeah, for self-driving cars and stuff, when you try to train your model, your neural network, you try to train your AI model, you can't just throw out your car in the streets of Antwerp and have it train and crash and try again. How do you efficiently, when you can't use it or test it in the real world, or how do you efficiently train your model if you can't immediately throw it out in the world, so to speak?
So it's definitely a question that I cannot answer because it's not my field, the application. Because I'm in our company, we are creating the circuit for the autonomous driving. We are not creating let's say the process around it. And I think it's more a question for the car manufacturer that they develop. I guess they have very sophisticated test system with all based about let's say software and modeling. They are modeling real situation, and based on that, they are defining which is the percentage of incident and of accidents. I think it is all about the models of the system.
Yeah, I would like to also add a bit on that. The question you ask is about whether you want to train your car directly in the car, and that's indeed a dangerous endeavor. And probably what you refer to is the more reinforcement learning setup, where you would like to crash your car until it learns. This you can do in a simulation environment. And then you go to the real world and collect data to make sure that your data is aligned with your simulator. So that's probably more along those lines. And indeed, I mentioned the opportunities for learning on the go. That's indeed a difficult question also for industry, because especially in the car industry, you would like to have guarantees that you're never going to drift in an unsafe zone. So that's indeed a very tough question, and for now still an open challenge. And I would say this is about a good combination of training in a simulator and making sure that the data matches the real world, and for that you need to gather a lot of data.
The other thing, of course, is you can take the car to Boston, and then it's okay.
Actually, in my recent visit to San Francisco, I realized that in competition with Uber, you can actually use, what's the name of that car company that offers driverless cars? So you can actually rent, sorry? Waymo. Yeah, Waymo. So Waymo, in fact, is operating, and it hasn't had any accidents, so it's allowed to operate in San Francisco. And I heard as of February or March, they also went to Los Angeles and a few other cities. So I don't know how they're doing this, but they have obviously trained their cars very well over time. Okay, next question, yes. Can you please pass the microphone?
Regarding connections in cars and getting the data from the central processing unit to multiple local processing units. Lately, I was looking at some research from K. Leuven. There's a lot of work being done in PMF circuits that work at above 100 gigahertz or so. And I was just wondering, in cars, how close is this on the horizon for communication between subsystems in a car? So, yeah, that's the question.
Yeah, so yes, there are a lot of innovation going on for sure, because we need to understand how to bring around all this amount of data, and this amount of data will be exponentially growing in the future. But what is also important to understand is that in the automotive world, everything will come later. Because you need also this function and safety requirements. So everything will need more test over lifetime. So everything that the company and the university are discussing now to increase the data rate, also with fiber, in the real automotive world will come a few years later for sure. But there are stuff ongoing, yes, in the innovation.
Yeah, if I may add to that, the how shall we say, the robustness requirements for stuff in cars is absolutely immense. And the promise of wireless networking in cars is absolutely there, because it works quite well most of the time. But the big challenge is making something that works always, and always. Yeah. So for illustration, some of these automotive networking standards like CAN bus, you are doing differential signaling at 2.5 volts differential, and then you're required to remain operational at any common mode voltage between plus 40 and minus 40. Yeah. And the common mode voltage can vary at any frequency between DC and 1 gigahertz. And we want to stay communicating and then doing data communication over a wire at 1 megabits per second, which could or maybe should sound trivial, is anything but. Thank you. Yeah, I understand.
Great. Let's go to the next question. One in the front and one in the back, whichever is closer.
In all of these presentations and in current designs, we see a trend to go to power. So power is always a performance metric. But at the same time, while we're trying to be more power efficient, use less power, we're also going for higher data rates, putting more functionality in cars, which then again uses up that power budget that we freed up. Where in your industry currently do you see the tipping point in which you would say the power is no longer worth it? To go more performance will just use up too much power, because we can always keep increasing it and burn more power, but we can at some point no longer say it's more power efficient, because it's not.
I'll wager an answer if you let me. I think there's an order of magnitude difference. So yes, we are concerned about power in all of this processing and networking and sensing and everything. Part of that is marketing. My device, for example, has to be lower power than Fabio's and vice versa. Part of that is real physics. We don't want the control units to become hot in the car. But everything you're spending on the radar, on LiDAR, on cameras, on networking is completely dwarfed by a few orders of magnitude by the power you spend on the drivetrain. So if I can do some brilliant intelligence with cloud computing and machine learning to plan my route, and I'm saving 5 kilometers or 5 minutes, it pays off. It's just the first answer that springs to mind. Maybe there are other views.
Go ahead.
Oh, you wanted to? Yeah. So I can confirm. So and I can add that it's a lot about marketing for sure in the industry. So of course, if you have two solutions with same performance, the customer will go to the one that consumes less. And overall, it is very important to have the full picture and see what is the total sum of device that you have, because now going the direction of all this integration, you will have really severe problem if not all the devices are optimized in power. So it is really a critical parameter.
Yeah, I fully want to confirm what has been said. Also, another metric is also, because there has been some feedback on that, that if you leave your car unused, you do not want to find it 1 month later with the battery depleted because the electronics leak so much. So there's also this long-term storage that is important. But yeah, I agree, it's very much dependent on the application. And for cars, given that the drivetrain is there and is going to consume much more power than your electronics, the power question is perhaps less important than in a phone where your battery has to leave at least a day. So very much depend on the application.
I can maybe still add to the question that it's, yeah, you can consume more power, but in the end, the chip also needs to deliver that power and gets hot. So you also need to cool down your chips. So that's also something you need to take into account in this story, I think.
Yeah, it's all kind of application dependent. You know, there's many applications where it's battery-driven device that the chip is going to be in, and of course, the more power you save, the longer it stays on. So, also, if it's a closed device, a handheld device, for example, it gets very little ventilation inside. So, thermal management is a problem. So that's power, and then you have the other end of the spectrum, like the data centers, okay, which threaten to shut down the entire planet if we don't figure out a way to do it more efficiently. You know, so that's kind of a universal power savings or power efficiency that we need to achieve, and the other kind is kind of application specific. You know, what is the IC going to go into? You know, and that determines what its requirements are going to be.
Great. We have time for one more question. Yes, middle. Yes.
So I was wondering, what are your thoughts on the importance of language knowledge? So is it worth to learn a third language besides English and your mother language, or not really?
Great question.
You mean, like, should you learn Pascal, or should you learn...
I'm looking like in Belgium, is it worth to really learn French, or like Austria, German?
I think you can get by very well using just English in the electronics industry, so you're good there. But if I may give you a piece of personal advice, then learn the language of the country you're living in, because it will make your life a lot more fun. And that's not just out of the blue. We're a very, very international profession and conference, and living in Belgium for the next 15 years of your life without a bit of Flemish or French is probably you're shortchanging yourself.
My suggestion is learn the large language model, then you know all the languages. Next, you want to have an answer? Anybody else wants to comment on this?
I think, yeah, indeed, with English you get very, very far. But sometimes, if your company, like where I worked at Huawei, is a Chinese company, and people start to talk in Chinese, it's sometimes useful you also understand them. So it depends on, yeah, do you want to get also the small things out of the conversation that they have, or are you okay with like the general lines?
In the early 90s, then, if you look to image sensors and cameras and so on and so forth, in the early 90s, there came a lot of interesting papers in Japanese. And then I started learning Japanese to translate Japanese publications, scientific, technical publications, so it's pretty limited to translate them in my own language. I never used it. Because then Google came with Translate and these kind of things. So it depends on what kind of purpose that you have in mind to learn a particular language. But by Japanese, I never used it. No.
Chris, do you want to add anything about Japanese?
Yeah, I've lived in Japan, and I definitely echo the sentiment that you should learn the language of the country you live in. It makes a big difference, and it helps you understand the culture and just appreciate where you are. I recommend that highly. And then, but I also know the situation where you're in a company where the people are speaking a language, you know, the people making decisions and controlling your life are making or having discussions in a language you don't understand can be a problem. So.
All right, with this, I would like to thank all the panelists. So please join me in welcoming them. And I would like to have the feedback and the quiz here. So hopefully you all have your cell phones with you. I didn't need to ask you because I'm sure you do. Just use the QR code and then go to the feedback. By the way, we really appreciate your feedback. I know that there's some questions. Some of them are multiple choice, and you could obviously answer them. But really what's important for us and for our speakers and panelists is to get your feedback. So please take your time to write at least a sentence or two about...
This is a great picture. All
taking pictures of you. So yes, please write your verbal comments as well on any of the topics that you heard or any feedback you have about Circuit Insights, how excited you are to participate again next year, and things like this. So we'll give you a few minutes to write this, and then afterwards, we're going to get a group picture. So you will be a subject of your own cell phone.